Okay, perfect. We are recording. Thank you for the reminder. So again, remember how mine is set up. I have a folder. If I click homepage, right? Here's the data here's the notebook we're working with, and here's the data folder. So all this right here is saying is read CSV, and it's starting in our working directory. Every time we do this version right here, it's starting in our working directory. It's saying from your working directory, find a folder called data, and in that find employee performance CSV. So here it is. Here's the data folder. If we open that up, find employee performance.csv, there it is. That's all it's doing, it's finding it. Now up here, it's doing the exact same thing with this, except it's doing it in 2 steps. And the reason why I like to use this way personally is because I can have a very long and complicated path. It can be somewhere external, like an external hard drive, anything like that. So you have the option to put a very long path here and then locate the data through that. But notice in this case, it's set up the exact same way. We're going to the data folder. In fact, I don't need that as capital. So it's a data folder is right here. And all this is doing is saying, join this path, which is just data, to this file. So essentially all it's doing is taking this, right, and joining it to this. So there's our path. Notice that this path is the same as this one down here. I just want to take a minute to show you the difference. It doesn't matter which one you use. Both will find us our file. I encourage you, all of you, to have it, at least for now, set up in the same way. Wherever your notebook is located, put a folder called data, and in that data folder, put all the data that we need for this particular lecture. All right, so let's go ahead and run that. And this is what you should be left with, right? It's a employee performance. We have a bunch of different teams. What are the team output? What is the base pay earned by that team? What was the quarterly bonus? Was there an annual bonus? Team earnings, adjusted rating for the team and for evaluation, average age of the team, and what employment class that team or those employees were a part of. Okay, so we actually don't even really care what all these are right now, because we're going to focus on one thing. Okay, we're going to focus on one particular column. And that column is going to be annual bonus. So let's look at people.info to get a sense of what this data looks like. So take a minute here. Try and interpret this yourself. Don't holler out an answer. It's going to take you a minute because you haven't done this before, but look through the different columns, comparing what you see here to what you see up here. Try and figure out what might be an issue. What might we want to look into, and why did you determine that? Any thoughts?
The count?
Sorry, can you say that again?
The count?
Okay, what about the count?
Well, it's coming up non-null, or is that not?
No, so that is actually okay. I can tell you what that is. Non-null is just saying how many non-missing observations are there. So for instance, we look here, we have 768 total entries, and we see team has 768 non-null. That means it has 768 non-missing. So it actually turns out, for instance, team has all of its data there. Something like team output's missing a few observations. Any other thoughts? Does something possibly jump out at you?
Why are there a whole bunch of 768?
Yeah, what's the difference between those numeric values right there? The 768, 763, 733, 541, 400.
Yeah. So there are 768 total observations in this data set. That's what this is telling us. This right here, let's do one line at a time. Says there are 768 observations that have actual data, non-missing or non-null data in the team column. If we go to team output, it turns out there's 5 missing observations, right? Because there's should be 768, but we only have 763 that are non-null or non-missing.
Okay.
This is telling us we have 5 missing observations. This is telling us we have 35 missing observations. This is telling us we have 227,
Okay,
368. Does that make sense?
Yeah,
yes,
Yeah, so that's all those numbers are telling us is how many missing observations do we have, or in this case, it's presented as non-missing, but typically people use it to determine if there are missing values. So I'm referring to something along the lines of D type.
the object,
Yes, exactly. The object, right? So we have something here, annual bonus. We look up here, annual bonus. What do you think this should be? What type of date on D type? Anyone can holler out.
integer.
Integer, yeah. And if you had said float, that'd be fine too. I mean,
Oh, yeah, float. Could have-
either one. I mean, what you see here is integer, right? So integer makes sense. That's what I would have guessed too. But if it had shown up down here as float, I would have said that's fine too. I don't care, right? But really what it comes down to is it should be a number. But we're seeing object. An object actually means that it is a string. So we think that it should be an integer. I agree with that. I think everybody agrees with that. But it's turning out that it's not being read as an integer. It's being read as a string. This is our first clue that we have something wrong with our data, right? We haven't even done anything with it yet, and we're already running into problems, something that we're going to have to address, because if we want to do any type of analysis, we want to do any type of work with annual bonus, well, it's going to be very hard to do any numerical calculations with a string. All right, so there's a lot of different ways to look at this. One very quick and easy way is let's just take our annual bonus column, and I could just print these out, but I'm going to actually save them here for just into a data set and then print the data set out. But we could actually just do this. In fact, we will. It'll be a little easier. We're going to run this, right? We're going to say, go to the annual bonus column, the column we have something going on with, and let's just look at all the unique values. And that's all this is going to do. So here's all of our unique values. For starters, it should be a string based on what we see here. And it is. Notice all of these quotes. All right, that's indicating that they're not numbers or strings. What object in here do you think is causing the problems? So if you look through all these unique values, does one of them stick out? And I can give you right now a hint, it is not NaN. NaN is actually correct, even though it's a string. Remember, it stands for not a number. And even though they're letters, that just means it is a missing value, and that's completely valid.
Just the decimal point by itself, the first
Yep,
one.
exactly. So whoever made this data set, right? Someone entered it, someone had to put this data into this CSV file. Whoever did that clearly put in some periods as missing. And that's actually not that surprising. A lot of data sets actually keep periods as missing values. It just depends what the formatting is. So it's not terribly surprising that that's the case, but we very quickly identified that the most likely reason we have an issue is this period, right? This is not a number. Everything else in here looks to be a number. This does not. So let's address this problem. What we need to do is fix this period. So you guys already know how to do this, right? Here's a quick and easy way. We haven't done any analysis, so let's just re-import the data set, okay? We're going to pass in, you did a problem like this similar, actually it was much harder in the homework, where you say NA values equal, and we're going to pass in this period because they're the decimal, because that's what we've determined is probably causing the problem. So to do that, here's our new data set, and I'm just going to scroll up to the original import, right? We know right away that it's actually done what we wanted in terms of replacing them, because the first observation was a period. Now it says NaN. And now we can double check this again by running info, and with any luck, we'll have corrected it. And that's exactly what we've done. Annual bonus is now a float. If it had been an integer, that would have been fine too. It doesn't really matter. We just need it to be a number, because now that it's a number, we can do numerical calculations. So we've already addressed what happens when we have some incorrect data, right? We've done it very quickly and easily, a couple of steps. We've looked through the data, we've quickly determined what the problem is, and we've addressed it. So at this point, nothing jumps out at me as unusual. I mean, there's some things we're gonna have to deal with. We have missing data, things like that. We might have outliers, we might have other things we have to do, but the data looks like it's at least formatted correctly. Okay, so this next problem or this next issue that we're going to address does require domain knowledge. And does anybody know what domain knowledge is when we refer to that? So it just means that you have knowledge of whatever field you're working in. So for instance, it would be considered domain knowledge and no other type of knowledge to know that in this data set, we cannot have team earnings equal to 0. Why is that? I don't know. Let's assume that it is something built into how this variable is calculated, or this company refuses to give a team earnings of 0, or we have some intimate knowledge that isn't general knowledge, right? We have domain knowledge of this data set, which means we have knowledge that helps us understand what these variables are. So let's say that we know anytime team earnings is equal to 0, that's actually an error because we know that that is not a possible answer, right? Every team has to have some amount of earnings. Even if it's $1, it just can't be 0. So using that knowledge, what we're going to do is look at the team earnings column, right? So here it is. But we're going to then filter it even further by saying go to the team earnings column and then find observations where team earnings are equal to 0. And if we do that, it turns out we've got, I don't know, a dozen or so observations that are incorrect. All right, so what would we do with these? What do you guys recommend we do? Right, we know these are wrong.
Set them to NaN.
Yeah, that's a perfectly valid choice. Set them to missing. That'd be my personal recommendation. What is an alternative that we could do?
You could delete the values, delete the
Yeah.
rows.
Absolutely, we could delete the rows. Now, anybody have any ideas why I'm choosing not to delete the rows at this point? So why would you choose not to delete these?
Does it have anything to do with taking out, like, well, I guess you wanted like 768, what is it, like rows here?
Yeah, that's pretty darn close, right? So the idea is we don't want to get rid of data unless we absolutely have to. And so at this point, we don't know what our analysis is. We don't know what questions we're asking. We don't even know if we're going to use this team earnings variable. So why delete it if it's missing, right? At this point, let's just set it equal to missing, keep it in our data, and we can delete it later on if we want. But if we delete it now, it's already gone. We have no option to get it back later. So we've already reduced our data set. We want to keep as much data as possible. So whenever you have the option to keep something, right, we know this is a 0, and it is completely valid to delete these observations. But we would rather delete them later on when we know that we don't want them anymore, or when we know that they're going to cause a problem, or when we know that we can't fill them in, rather than deleting them right now at the beginning, right? Because right now we don't know what's going on. We don't know what the data is going to look like. So we're just going to keep them, right? But we're going to keep them by, as Denny said, setting them equal to missing, right? So this is the exact same code as above, where it's going to filter these. But rather than just filtering to them, we're going to actually set them equal to missing, NP, which is a NumPy library, which is where NaN is from. We're going to set them equal to np.nan. And I'm just going to filter them again. And you can see observation 9, that's index 9, went from 0 to NaN, 706, 0 to NaN, and everything in between. So at this point, we've now cleaned up our objects or our strings, which are incorrectly formatted, and we've removed some errors from the data. So we're working through this data set to slowly clean it.
Dr.
Further
Stark,
questions?
could you remind me like what that np.isnan mean again? Is it just
Yeah. So it just says is nan, right? So NumPy is missing, is not a number. So that's all that's doing, is it's pulling only observations where team earnings is equal to NaN. And there's other ways you could have written that, but this is just a quick and easy way. np.isNaN.
so is that the same as that first line?
No, so this first line right here, right, we're pulling all of these zeros. We're pulling these exact same observations, right? Because it's the same code as this. And then what we're doing is we're setting them equal to missing. Does that make sense? So we're replacing the zeros with those.
Mhm, yeah. That
Now, if we
first
did
one
this
makes
again,
sense,
we're not
but-
gonna get anything. If I run this cell up here again, we're actually not gonna get any of these observations because they're no longer equal to zero. They're now equal to missing. Right? So we have none. So we can't filter based on zeros anymore. Now we have to filter based on NaNs, and that's just a quick and easy way to do it. NP.isNaN will only find those that are or do have values that are NaN.
Okay, so the NP.isNaN is just a filter.
Exactly. Yep. It's filtering only missing values.
Okay, got it.
Yep. So now we're only keeping those missing. Perfect. All right. So let's ask this next question. Here we have a new set of data, worker sales. Here we have it. I don't even at this point know how many observations there are. I don't know anything about the data other than I can see a few observations here. I know there are some missing values without even looking because I can see them. But I want to know how many observations are missing, and equally important, what percent are missing. So why would I care about both of these, right? Why would I care about number and percent? Anyone? Well, is 10 missing observations a lot?
You may not see a lot, but
It
the
would
percentage
depend on
might
how
show
many
different.
observations you took.
Sorry, DeAndre, go ahead.
If 10 missing observations was a lot, it would only depend on like if you took a bunch of observations.
Yeah, it does. That's the thing. It depends, right? That's the key there. It depends. Is 10 a lot? I have no idea. 10's a ton if we have 11 observations total. 10's probably not very many if we have 1,000,000 observations, right? So knowing the number of observations that are missing is important and useful, as well as knowing how many or what percent is missing, right? 90% missing is a lot more than 1%, but they could be the same numbers. So we're going to look at how to do both of those, and it's pretty straightforward. So we're just going to make a new data set called worker null from this data set. And all I'm going to do is say worker.isNull. It's going to go ahead and evaluate every single one of these cells. If it's null, it's going to fill it in with a true. If it's not, it's going to be false, right? So you can kind of see here, the two missing values are true. Everything else is false. And you can imagine it's doing this throughout the whole data set. So can anyone remind us, what is the value of true? What numerical value does it take on? Does anyone remember?
It's doing like a Boolean mask.
Yep, it is. So what, do you know what value true represents? What numeric value?
One.
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 Yeah,
One,
exactly. True is 1, false is 0. Okay. And that's a unique aspect that allows us to very quickly count trues and falses and know exactly how many are missing, or in this case, how many are missing, right? So we have all these trues and falses. If we just simply say dot sum, we know there are 37 missing sales. Why do we know that? Because if we add up all the falses and they're all zeros, then 0 plus 0 plus 0 doesn't matter. They're all zeros, right? If we add up all the ones, we have 37 of them that are missing. For costs, we have 7 missing. And then for workers and hours, we have none. Now, again, is that a lot? We could kind of figure this out by also doing info or seeing how many observations are in this data set. But it's also easy for us to get an actual percent without trying to figure it out manually, right? So if we know all the values are 1, rather than taking a sum, let's just take an average, right? A dot mean. And I just multiply it by 100 to make it decimal, make it percent. You can leave it as a decimal, it doesn't make a difference, right? But in short, we know that about a quarter or almost a quarter of the sales observations are missing. Almost 5% of costs missing, 0 of obviously workers and hours. So just some more information we now know. We know 37, is it a lot? Well, it turns out, yeah, it's about a quarter of the observations. Is 7 a lot? I don't know. You could kind of be the judge of that. 5% is getting up there, but you know, we can work with that. There's no hard and fast rule. It doesn't say if you have certain percent, then it's a lot. If you have under that percent, it's a little. You just kind of have to make that judgment. But we very quickly now know what percent of our data is missing. Now we're going to use a new library You may or may not have this already installed. So here's what I'm going to do. Follow along. You probably haven't done this yet. So just a reminder, when you're in this cell, hit escape. If you're in Jupyter Notebook and you're in Google Colab, just add another code cell. I think it's at the top. But if you're in Jupyter Notebook on your machine, hit escape. This will turn blue. Hit the letter A above. We get a new cell right here above. And you want to type in pip install missing no. If you're looking at what it is, it's just right here in the comments. I just copied it. Now I'll run it. And it's already satisfied for me because I've already put this in here. You may or may not have in here depending on what version of Anaconda you have, but either way, once that's in there, it's done. You don't have to reinstall it. I'm going to hit escape again and turn this blue once it's installed. Once that's blue, I'm going to hit X, and now that's gone. All right, so now I've installed it, and you've hopefully installed it on your computer as well. So we're going to go ahead and import that, and we're going to use this next little bit of code, depending again on what version of Jupyter Notebooks you're using. You may or may not need it. I always put it there because it's just safer. It doesn't do anything if it's not needed. If it is needed, well, you need it. But all this is doing is matplotlib inline is just saying, show me my graphs. And this, we're going to make our first graph. Show me my graphs right here in my notebook. So if you don't have this and you try and run this cell and nothing shows up, well, you'll know that you do need it. All right. So we're going to go ahead and say MSNO, which is this new library, missing number or missing no, .bar. We're going to pass in our data set. So we're going to get a bar chart. So here's a visualization of missing data, right? This is a very basic one. It's not terribly helpful. We can get the same information from our info, right? If we said worker.info, it'd tell us there's 116 non-missing, 146, 153, and 153. So we can do this, but it is here if you prefer a visual representation of it rather than numeric. But what's more interesting and what I find very useful is this matrix. So MSNO.matrix is going to help us visualize if there's patterns, right? Where are the missing values located? And this is actually incredibly helpful because it shows us a visualization of our data stacked on top of each other, all the observations, and 1 through 153 in this case. And it shows us where the missing data is. All the dark areas represent data. All the white areas represent missing values. So it tells us two things really, or two important things. One is the data that's missing spread out randomly, or is the data that's missing large chunks? And it turns out there's for sale, it's some pretty big chunks of data, and this would be a problem, right? This becomes difficult if there's some relationship to this data, right? If this data is ordered, maybe it's a time series, right? These are days in a year, whatever the case may be. If we're missing a month of days consecutively, that's a big problem. Whereas if instead we're just missing a random day every month over the course of 10 years, well, that's not such a big deal, right? We can probably fix that. But if we're missing an entire month of daily trading data, for instance, well, that's a big problem. That's going to be very hard for us to deal with. So we can see we ideally would have relatively small spread out missing values, not large chunks like this. The other point of interest is in this data set is pretty small, so we can visually see that this line lines up, right? It's white across sales and cost there and here. But if it's a larger data set where we can't visually actually trace a line across, this line on the right, or this little unique looking graph on the right, actually tells us where the most data is missing. So anytime it's flat, that means it has all the observations. Anytime there's this middle height, that's telling us that there's one missing observation, right? So we could know that all of these have one, and then you can see this right here and this right here have only two observations, right? So we know that these two peaks represent, if we trace them over, these two areas, and it's telling us that not only does that observation have missing sales, but it also has missing costs. That's informative because maybe these are, whatever these observations are of, we know that there's multiple pieces of missing data for that observation. So maybe worker, B has 2 pieces of missing data, and maybe worker, I don't know, R has 2 pieces of missing data, but all the rest only seem to have 1 or none. So that's also another way to visualize what is missing in our data. So any questions on reading this, or how we're going to go about finding out what our missing data is? All right. So let us drop some missing values now. This was another suggestion at the beginning, and it is a completely valid suggestion. So I have made a data set. Don't worry about what is actually being made here. Here's what it looks like. It just has a bunch of missing values. All right. So if we have a data set and we want to drop missing values, we can say data.drop NA. And it's going to drop all rows that have missing value. So what is our output going to look like? What do you guys think?
1.0, 6.5, 3.0, right?
Exactly. Yeah, right. So we're only gonna be left with row 0, or as she said, 1, 6.5, and 3. That's exactly right. Okay, drop NA by default drops all rows that have any missing values. Alternatively, we can go on the other extreme. Instead of having any missing values, we can require that a row have all values be missing in order to be dropped. In this case, what's going to be dropped?
Just index number 2.
Yeah, exactly, right? Index 2, row 2, or row index position 2, however you want to say it, is the only one that has all missing values. So we can make it so that it's very restrictive in what it drops. We can make it that it will barely drop anything. You have to have all missing values, right? This one I think makes a lot of sense. I could see many times that this would have a good use case, right? If I have no valid observations for, something, it's gonna be very hard for me to, justify keeping that.
Dr. Stark,
Yes.
what is so the how has ran up in like our previous assignment before, but could you kind of explain what the how does here?
Yeah, it just tells what argument you want, right? So in this case, how we're saying that we want all of the observations to be missing. Does that make sense?
So like in this case, how is what does I'm not entirely sure how to ask it because I'm not sure how it works here.
It's how the data is going to show up when you
Yep.
when you run the code.
So here are your 2 options, right? This is actually the pandas documentation for it. I just Googled pandas pandas drop NA. And all you're doing is you have the option to put in any or all. The default is any, right? So this, here it is. The default right here is like doing this, except we don't actually have to type it in because that is the default value. But if I run this right now, what's going to happen is it's going to actually give us the exact same result that you see there. Right, so it's saying, how is it going to determine what to drop? Well, anytime there's a missing value, we drop it. How is it going to determine what to drop? Well, anytime all of the values are missing, it's going to drop it. And those are the only 2 options that are built into this. Any and all.
Okay, that makes sense. Okay.
Yeah. So those are the 2 extremes, right? We've dropped any and we've dropped all. We've done that for rows. We can also make these same arguments for columns. Does anyone remember how we do that? Right? We can pass axis equals 1, or what is the other way? Axis equals what? Right, we can pass in the word columns. Remember, we can pass in the word columns if you remember that as an easier way of doing it. But again, axis equals 1 is now, instead of going across the rows, we're going to go down the columns. And if we're going down the columns, what is the output going to be here? Right? We're dropping missing columns. What is going to be the outcome?
I think you're still going to be left with the zero index because each column, well, no, every single one of them,
Yeah, so nothing, I don't know.
nothing.
Yeah, that's exactly right. Nothing, right? Every single column has a missing value. Remember, the default is how equals any, right? We don't have to type it, but that's the default. Anytime there's a missing value, it's dropped, and they all have missing. And we can do the exact same thing, how equals all. In this case, we're keeping them all because no column has all missing values. So let's make another data frame, right? Just reminder, drop NA, right? We're getting rid of 0 through 3. But what if we want something in the middle, right? So far, what we've done is we've looked at any and we've looked at all, but those are just the two extremes, right? We want to have something that will allow us to move in between those two extremes. And that's where thresh comes in for threshold, right? And actually, since we have the documentation open, let's just look at it. Thresh, it's an integer. It requires that many non-NA values. So what does that mean? Well, how many observations do we want to require? In this case, I'm just putting in 2. So this means we're requiring at least 2 valid observations to be kept. So if I'm requiring 2 valid observations, what is the outcome going to be from this? Right, this is our original data set, this one in 27. If I require you to have at least 2 valid observations, what is the outcome going to be?
Are you just dropping the first 2 rows?
Exactly. Yep. I'm just dropping the first 2. Let me zoom out a little just so we can see them for this little part. All right, so here's the original up here, and here's the new one. Thresh of 2 says we need to have at least 2 valid observations. Well, 0 has 1, 1 has 1, 2 has 1, then missing, then 2. So there's 2 valid observations here, and obviously everything below that also has 2. All right, so let's try one last one. If we have an axis of 1 and a thresh equals to 4, and this is our data set, what is the outcome going to look like?
Next 4 columns that have NaN in them, they'll all be dropped.
Sorry, say that again.
The next 4 columns with NaN in it, they will all be dropped.
So which columns
right.
do you think will be kept or dropped? Or everyone?
Well, you'll just keep the first one, the 0, column 0.
Okay, why would we not keep 2?
Assume because there's the NaN in there.
Right, but remember, we have thresh equals to 4, which means we need to have at least 4 valid observations, and column 2 has 1, 2, 3,
Oh.
4, 5. So we actually end up keeping 0 and 2.
Yeah,
Right, we only would drop 1 because it has 3. So at this point, we have the ability to go either extreme, if you have any missing, if you have all missing, or we have the ability to pick any number in between by using thresh instead of how.
So threshold only
Over-
drops if there's like 4 NaNs, is that right?
Say that again?
The threshold only drops it whenever there's 4 of them, like
No, so
specifically 4 of them.
thresh says in this case, how many observations do you need to have? Right, so I need to have 4 observations. This one actually has 5. So if I can put a 5 here and we do it, you're left with the same thing because there's 1, 2, 3, 4, 5. Now, if I put a 6, we know that 2 only has 5, so it will not be kept.
We're looking at the columns right now, right?
Yep.
Okay, thank you.
Yeah, no problem. Yeah, we're looking at columns because it is axis equals 1.
Okay,
Yep, so if you count down, if we wanted to keep column 1, we need to have a 3 here, right? Because there's only 1, 2, 3.
Okay. So each column with anything that's greater than 3 that are not NaN values, you'll be keeping.
Exactly. Yep, and then again, it works the same way like we did up here. If you didn't want it to be columns, you want it to be rows, you just don't put axis equals 1. All right, so let's talk about keeping missing values. We've already discussed why we prefer to keep them. In the notes that you download, do have an additional section, and you're welcome to look over that. And I do actually talk about it in the recorded lecture. But it's a little bit more in depth than I want everybody to have to learn. So the idea here is, how can we keep missing values? Well, the only way to keep missing values is to fill them in, right? The way in the notes, the extra part is going to do something called simple imputer, but we can also accomplish a lot of what that's doing right here with some very simple code. So if you want to go through the extra part, you're welcome to. You have access to those notes. But if you just want to focus on, these parts right here, which are also in the notes, this is more than enough. All right, so we already know. What did I do? Did I not import it? Just a minute. Oh, I think it's called people. I think that's why. Oops, let me just import this again. There we go. Okay. So here we have the file we've been looking at, performance, right? I'll even quickly just show it right here. Right, it's this one that we've been looking at. Here's the annual bonus. We've corrected it the way we want. Now the idea is, let's try and fill in these missing annual bonus values. Instead of dropping them, let's try and do something to fill them in. What are some ideas of how we could fill them in? So if I said we need to fill in these missing values, what would you fill them in as?
0.
Perfect. That's a valid option. Any others? There's lots of options and there's no right answer.
Forward fill, backward fill,
Sorry, can you say that again?
F fill, B fill.
Yeah, we're going to talk about that a little bit later on. Any other guesses? Any other ideas? I mean, we can do simple things, right? You guys said, oh, Kimberly, you have an idea?
Maybe is null, I don't know.
Yeah, we can have those null values, but I want to know, so if we want to keep this, right? We want to keep these missing values, and we want to fill them in.
Mhm.
Right, Denny, I believe it was Denny, said you could fill them with 0. That's perfectly valid. What if
Could-
we also, oh, go ahead.
Could you just, I don't know, can you just leave it space?
Yep, so I don't even want to do that. Maybe I'm not explaining that what I'm asking. So we want to fill them in with a number, right? I'm telling you, you have to fill them in with a number. What are some options for the numbers we could fill them in with?
0.0.
Yep, beyond 0.
Can we
Any
do
other
something
thoughts?
Random?
We could do a random number, yep. What about just calculating the average, right? What about the average bonus that everyone received?
Yeah.
Yeah, we could fill in with the average, we could fill in with the median. There's a lot of options we have, and I'm going to show you a couple of them very quickly. But more importantly, I'm going to show you how your decision of what to fill in impacts the data, right? It's actually a decision that is very important, even though it doesn't maybe seem that important. And there is no right answer, but because no matter what you choose, you're going to be changing the data. And ultimately that could change the results in the end, right? It could change your analysis, it could change the outcomes. And there's no way for you really to know what's going to happen until you actually do it and explore what that impact was. All right, so we have a bunch of missing values. Here we go. We have 394 annual bonus values that are not missing. Because when we do describe, it's going to give us the descriptive statistics of our data set, in this case, just annual bonus. So you can see we have an average of 155, standard deviation of 118, minimum, maximum, and so on. What we're going to try and do is remove 394 and actually make that the 760 or whatever it was, right? We want no missing values. So how we're going to do this, I'm going to first go ahead and fill it in with the average. So I'm going to take our performance. I'm going to say .fill NA. And I'm actually going to fill all the columns with their own individual average. It doesn't matter. We're just going to focus on annual bonus. So I'm going to say take the data set, calculate the mean, and that's what's going to be filled into all those missing values. Right? Does that make sense? We're going to have a new data set that's equal to our old data set dot fill NA, which means we're going to fill in the missing values. What are we going to fill them with? Well, we're going to take the average values from each of the columns. So that's a simple way to fill in the average. Very straightforward. We're going to now look at the outcome. And notice we did in fact have all those missing values go away. We are left with 768 non-missing annual bonus observations. So we've accomplished what we wanted. But what's going on with the data? Who can describe what happened to it? Did the mean change?
No,
Oh, standard
Right.
deviation change.
Why? Well, first, yeah, you're right. I'll get right to you. Why did the mean not change? Right? What did we do?
you filled all the NAs with mean.
Yeah, so if the mean is 155 and I filled in 300 observations, 400 observations with the value of 155, well, that's not going to change the average, right? We're just putting a bunch more of those averages in there. But what is that doing to the standard deviation? Regina, I think you were the one who had mentioned it, or we're starting to.
It did go down.
Yeah, right. So we've reduced the standard deviation or the variance of our data. And why do we do that? Or how do we do that? Well, instead of having data spread out like this, right, we've added 400 observations right there in the middle. So we're shrinking down that variance. We've changed what our data set looks like, right? The distribution of our data is much different. The minimum hasn't changed. That makes sense. The maximum hasn't changed, right? We're not doing anything to the extremes. We're adding everything to the middle. But notice we've also changed the 25th, 50th, and 75th percentile. So we have made some pretty big changes to what our data set looks like, right? The distribution of our data is vastly different now from just simply adding in the mean. So you can see really quickly here how, because our data is now so much different, how the outcome of our analysis might be different. All right, so I think Denny said one of the options we could fill NA or fill in missing values with 0. Take a minute, don't actually run this if you've got it up, and think about what putting in zeros is going to do. When I run this and I show us the describe of this, what is this all going to look like, right? We know counts can be 768, but what are all these other numbers going to look like? Think about what's going to happen to the mean and the standard deviation. All right, so I'll run this. All right, we're now at 768, which is our goal. We filled in the missing values. In this case, we filled them all in with a constant. We just filled them in with zeros. So what have we done to the mean?
You dropped it by almost a half.
Yeah, think about why, right? We've added almost 400 zeros to this data set. So we've added a ton of really small values. In fact, the smallest value. So much so that the first quarter, at least the first quarter of our data set are all zeros, right? And it's probably a lot closer to 50% that are all zeros. We just don't have that cutoff. So assuming that these people with missing annual bonuses actually had a 0, again, has a huge impact on our data set. We have a vastly different data set now than we did before. So the decision to fill in missing values and how we do that is incredibly important. And unfortunately, there's no right answer. Really, when it comes down to the real world, what you're going to end up doing is doing something like this. Let's say we want to just fill in the mean. We're going to run our analysis. We're going to see what our results look like. We're going to then come back and fill it in with 0. What do our results look like? Are they different? How are they different? Why are they different? We're going to come back and we're going to do it again without filling in. Maybe we're going to drop these values, and you're going to keep doing these different things to see what is the impact on our data sets. All right, so let's talk about F-fill and B-fill. All right, these were just mentioned a minute ago. So let's assume that we have a time series, right? We have stock data. We have quarterly or monthly reporting. We have daily, I don't know, reports that go off to managers. We have something that is ordered, right? And what I mean by ordered is pretty simple. May 3rd comes after May 2nd and before May 4th, right? Things go in order. I can't just randomly sort this data. I wouldn't have May 3rd after April 7th before, January 1st and all of this. So when there's an order to the data, we actually have an additional way of filling in data or filling in missing observations, that we can take advantage of the fact that something that happened on May 3rd is probably a lot more similar to something that happens on May 4th than it is to something that happened on December 2nd, right? These 2 days are very close together. They're more likely to be similar than something 3, 4, 5, 6 months away. So taking advantage of that, we can do F-fill, which stands for forward filling, or B-fill, which stands for backward filling. Okay, so I'm just going to take this data set and I'm just going to slice off a small part of it. I'm pulling these ones because I know there's missing values there. And here we have it, right? We have May 31st has a value. June 7th has a value. Excuse me. Everything in between is missing. Right, so we could do what we did above, fill them in with zeros, fill them in with the average. But instead, what we can do here is we're going to look at 3 different ways to fill them in based on the fact that this is ordered data. The first one, we're going to have fill NA just like we did before. Rather than putting in, dot mean or putting in a number like 0, we're going to say method equals F fill. And again, F just stands for forward. So we're forward filling this. What do you think is going to go into these missing values? What would be your guess just based on the name of this?
37.
Yep, exactly. Right, we're going to forward fill. And how forward fill works is it's going to take this value. Well, it's going to take every value. It's going to evaluate 23 and it's going to say, okay, this next observation, oh, it's not missing, so it's 45. Oh, this is not missing. Okay, 37 is the next one missing. It is. So it's going to forward fill 37. And it's going to say the next one missing. Okay, keep filling forward 37 until it says, okay, 29 is not missing. We're done forward filling 37. So that's going to take 29 and try and forward fill. Oh, it's missing. 29 goes here. All right, so when we run this, you can see May 31st is the 37 that we have up here. And then it has forward filled all of those down to June 6th. So it's just forward filling, taking advantage of the fact that the first comes after the second, or before the second, before the third, the fourth, the fifth, the sixth, and so on. In contrast, backfill just does the reverse, right? We come up here and we want to backfill this. We're just going to take 29 and fill it backwards. And that's exactly what happens here. 29 is on the 7th, and it's just been filled back 1 day at a time until we connect to that May 31st date.
So why would you manipulate the data like that?
Why would you? Well, just simply if you believe that something that happened on June 1st is, well, I'm going to come up here to the empty one because it's easier to talk about. If I believe that what happened on June 1st is more likely to be similar to what happened on May 31st, then other options would be to, take the average. Maybe I have reason to believe there's seasonality, right? Maybe I have reason to believe that, the data that happened in a different economic condition that we had maybe in December shouldn't be incorporated in this. So maybe I don't want to take just the average because it's going to take into effect all these different things that aren't similar. So if you do not believe that something that happened on, let's say, the 31st is more similar to what happened on the 1st, right? The proximity of these two, if that doesn't matter to you, then you would not want to do this, right? This is only applicable if you believe that there's something in the data that says dates that are close by should be similar to each other. If you don't believe they're similar based on that, I wouldn't recommend doing this at all.
Okay.
All right, so the last one we're going to do is, at this point, what we've done is we've said, okay, let's just copy the same date, right? Whether it be 37 or 29, let's just copy it a bunch of times. But what's really happening is we have a bunch of missing values. We know this is 37, we know this is 29. Maybe what we really want to do is just connect these, right? Connect them in equal size steps so that we, in a linear fashion, go from 37 to 29. We don't think it's going to be all 37 and have one big jump. And we can very easily do that too, right? We can very easily connect 37 and 29 with equal space steps. And all we're going to do for that is, instead of saying fill in A, we're just going to say interpolate. And we're just going to fill it in with a linear connection. So when we do that, here are our dates. There's a 37 and there's a 29. Whereas before, we either calculated the number 37 and filled it in a bunch of times, or going backwards, we took 29 and filled it in a bunch of times. What you notice here is we've actually filled in all of these values that are highlighted. Connect 37 to 29 in equally spaced steps. So if you were to calculate the difference between any two consecutive values, they are going to be the same. We're making that so it is a straight line between the two. Right, you can actually see that right here, 29, 50, 71. 29, 71, so 50, right? It's a lot easier to see it here because it's just only one number. But you can see what we're doing now is, if you don't want to have a bunch of values repeated and then one big jump, you can actually connect them through, equally spaced sizing. Any questions? All right. These next couple points are pretty straightforward and easy. So we have a series like this, right? We have -999, -1000. There are actually many data sets that will put in negative numbers to indicate certain things, right? So for instance, sometimes when a stock doesn't have a closing price, depending on what data set you're using, it'll put in, let's say the closing price that they record is $10. They'll put in a -$10 if they've had to calculate that price, right? Sometimes they'll calculate it by the average of the bid and the ask. And it's not the actual close, it's the closing price that they've had to calculate. If that's the case, what they'll do is they'll put it as a negative. So instead of putting in $10, they'll put in -10, so you know, right? You'll know that you can't have a -$10 price. That's not accurate. So we need to do something with that. But in short, what it tells us is sometimes, unique values are used to indicate something. Let's assume this is what our data set has, and we have some -999s, which means something, and -1000, which means something else. It doesn't matter what they are. Well, we can actually just really quickly replace these values with the values that we want. So let's assume -999 should be missing. We can simply say data.replace and pass in two values. The first one is the one you want to remove. The second one is the one you want to replace it with. So in other words, we want this to be missing and this to be missing. That's exactly what we've got. We can do this with multiple values as well. All right, so we can pass in a list where we want all of our negatives replaced at once. Okay. And we'll even be able to do that. Now we've got all of these replaced in one step. And finally, maybe 999 should be a value that is missing, but maybe -1000 actually should be replaced with zeros. Right, so we can actually have as many unique replacements as we want. -999, -1000, they're going to correspond to here. 999 is going to be missing and 1000 is going to be 0. You can see that we can replace values very quickly and easily. Here's our missing and missing, which were our 999s, and our 0 is our 1000. So any questions on replacing missing values, dealing with missing values, anything at all about missing values. It's very important. We've covered a lot in it. We've looked at a bunch of different ways and reasons that it's important, but that'll kind of do it for the missing value part of the lecture. All right, let me see where we're at. All right, so it's actually not that much more for this evening. Let's just talk about this one section and then we'll get a quick break and then we'll come back and finish up. So does anybody know what binning is or what bins are when someone refers to creating bins for the data? I'm sure we've all seen them before, and if you don't realize it, think of a survey. All right, what are some survey questions that typically come in bins? So when we ask, or when you answer, if you get a survey, you'll typically get, what is your, if it's asked you your salary, does it ever ask you for your exact dollar salary, or does it usually give it in bins or ranges, right? It'll usually say, do you make 0 to 30, 30 to 50, 50 to 75, 75 to 100, whatever the case may be. Those are bins, right? We're trying to take a continuous variable and put it into different groups. And we can actually do that really quickly and easily in Python. So if we have a bunch of prices and I want to create some bins, right? These are some randomly assigned bins. No real reason why I have these as a cutoff, but I've got bins of 18, 25, 35, 60, and 100. So I can say pd.cut. I can pass in my list of prices and the list of my bins. Let's look at it. Because this output is pretty confusing. It's unique. It doesn't look like we'd normally do. The output for this, CAT just stands for categories. I just call it that. Right? Rather than getting out these values, what we're getting out are these strange looking sets of numbers. What this is telling us is this first value falls in the bin of 18 to 25, right? That bin was created by Python for us based on these two values we put in. So here's 18 to 25. This next one is 18 to 25. This next one is 18 to 25. 27 falls in the bin of 25 to 35, which is just simply that set. If we come out here all the way to 99, well, that's going to fall in the bin of 60 to 100. So the bins that it's creating for us are 18 to 25, 25 to 35, 35 to 60, and 60 to 100. And all it's doing is telling us which of those bins this falls into. So if we want to actually see what these categories are, it'll actually tell us what they are. These are the options, because again, there could be a lot of data here. We could have many bins. You might not see them all. So here is what they are. It'll tell us how many fall into each of these as well. You can see how this might be useful if you want to go ahead and classify, let's say, mutual funds. Are these growth funds? Are these value funds? Are these hedged funds? Are these, international funds? Are they small cap or large cap? You might want to create different bins to sort your mutual funds, or maybe you want to create bins to sort your stocks or whatever, your companies into dividend companies and non-dividend companies, or whatever the case may be. You can see how bins could be used for sorting purposes. So we can do that really easily. But also what's a nice feature is we can pass in this argument to our bins. So pd.cut, just like we did up here, but adding a third argument, we can actually add our own labels. So I've just made up some simple ones, but maybe instead you would have, like I mentioned, maybe one would be growth, one would be value, one would be mixed, one would be international, and so on. But here we have cheap, almost expensive, and expensive. And notice there are 1, 2, 3, 4 labels. And there are 1, 2, 3, 4 different bins that are being created. So you do need to have an equal number. This will correspond to cheap. This will correspond to almost cheap, almost expensive, and expensive. So they just line up with each other. So now when we do it, rather than getting these labels 18, 25 or 60, 100, we get the label cheap, 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 almost cheap, expensive, and so on. So it's a little bit more informative to us, assuming those labels actually make sense. So if what we want to do instead is to distribute the bins evenly, right? I'm going to make a data set of 20 random numbers. I'm going to say pd.cut, right? I'm going to pass in my data, just like above. I passed in price. Here I'm passing in these 20 random numbers. But instead of passing in bins, like I did above, right? I'm not going to define where I want these cutoffs to be. I'm just going to pass in 4, and precision just says how many decimals to use. And let's look at what happens. Right. What this is doing is it is creating 4 equally sized bins. Don't look at how many observations are in each of these bins. I know it says there's 6 in this, 5 in this, 5 in this, and 4 in this. That's not being equally distributed. What's being equally distributed is the low and the high value for each bin, right? So this is about 0.23, right? That's the spread between that bin, right? The low value and the high value is about 0.23. Just like you could say here, the spread between 18 and 25 is 7, 25 and 35 is 10, 35 and 60 is 25, and 60 and 100 is 40. That's what I'm talking about. Each of these is an equally spaced out bin, and it's determining what spacing is required so that all the observations in the data fall into a bin, right? So if we want to have equal distributions of the bins, we can do that by just passing in a number of bins that we want, right? If we want 7, there are 7 of them. You know, if you want 2, there's 2 of them. Doesn't matter. It is going to calculate how big or small those bins need to be. Now, if instead you want to, let me put this back to 4. Oh, it was. If instead, or maybe it was a 5, I don't know, it doesn't matter. If instead what you want to do is make sure that the number of observations in each bin matches, right? We don't care what the bin cutoffs are. We just want to make sure, excuse me, each one has the same number of observations. Well, we can do that too. So let's get 1,000 random numbers. And instead of using cut, we're going to use qcut. And we're going to say make it into 4 bins. The idea here is we should have 250 observations automatically placed into 4 different bins. And that's exactly what we have. Now it's calculated what these cutoffs are for us. Remember, this first one's about a value of 2, right? There's about negative 2.7 to 0.65. You can see this bin right here is pretty small, and this one's pretty small. So it is automatically calculating what those different cutoffs should be to ensure that the same number of observations fall into each bin. So again, it's not an incredibly common thing that you're going to use, but there are cases where you're going to want to know how to do this, and it's actually a pretty easy thing to do. So has anybody here heard of indicator variables or dummy variables?
Yes, dummy variables, yes.
Perfect. Can you don't have to, but could you explain what they are?
Not really. I know it just pops up like when I'm running like a reconciliation, sometimes it'll pop up. Like we'll have something say scroll or dummy.
Sure, that's totally fine if you aren't sure. I'm glad you've at least heard of them. So if you hear the word dummy variable or indicator variable, they're interchangeable. They mean the same thing. Here's a very simple data set. And I've got a data called key, and I've got a data column called data 1. I've got BOA, I've got a misspelled apple, right? Ticker APPL as well as AAPL. I've got C and I've got VOA. Okay, so if I say PD.get dummies, get dummies is going to be actually very important for us. So if we're going to run a regression, which later on we'll run some regressions. We need numerical data in our regression. These are not numerical variables, but maybe I think something unique is happening based on what company you are, right? Maybe I think Bank of America has some impact on our results, but I can't use Bank of America. I can't use BOA in my regression. So what can I do? How can I convert this to a number, right? How can I convert this to a numeric variable that will allow me to use it in some analysis? Well, one very simple way is get dummies, or again, indicator variables, if that's the name you're familiar with. So pd.get dummies, I'm just going to pass in my data frame and the column that I'm interested in this case, key. run it, and there you go. Notice what's happened. It is only now returned to us key, because that's the column we're looking at. And try and figure out what it's done, right? Take a minute to look through, how did we go from this one column to these 4 columns filled with zeros and ones? Anybody figure it out and explain it to us?
The dummy variable is just a placeholder so that you can run a regression and see the different and control for the variability in the regression.
Yeah, so how did we, that's exactly right. How did we get this first column? Like, what are the very simple steps? How did we get a 0, 0, 0, 0, 1, 0?
You set it to either 0 or 1 for yes or no.
Yep. So what's happening is exactly right. We're setting it to a 0 if the answer is no, and a 1 if the answer is yes. Well, what is that answer I'm talking about? Well, in this case, AAPL, that's the question, right? The question is, does the variable equal AAPL? Because that's what that column's called. Well, no, so it's a 0. No, it's a 0. No, it's a 0. No, it's a 0. Yes, it's a 1. Notice 4 is the only one we have. BOA is 0. Then we'll go to the other apple, right? No, 0. No, 0. Yes, 1. 0, 0, 0. And lastly, I'll just do BOA just because there's a bunch of them, right? BOA is a 1. BOA is a 1. 0, 0, 0. 0, 0, 0. And lastly, BOA is a 1. So that's all it's doing. That's how it's converting one column of string variables into, in this case, 4 columns of numeric variables. Right now, we can go ahead and actually use these 4 columns in a regression, and we'd be able to say, okay, well, this is the, whatever our coefficient is here, this is the impact of AAPL, this is the impact of APPL, this is the impact of BOA, and this is the impact of C. And lastly, just one quick additional argument. If you want to say comma prefix equals, because these aren't really informative, right? Originally, this was a column called key. So maybe key was important, right? But notice here, key is no longer there. Well, we can add a prefix. And now I'll say key apple, key BOA, and key C. Just if you want to have some more informative data, you can add a prefix to those. So any questions on dummy or indicator variables before we take a short break? So let's talk about outliers, group by, and then combining some data, and we will call it a night. I'll get you out of here probably in 2 hours total. So outliers, who knows what an outlier is? Oh, hold on. We got someone joining back in. All right, so who knows what an outlier is? Or what are we talking about when we say outliers? Any ideas? What do you think one would be, just from the word itself? Because I can tell you it's not a trick word.
Something outside the normal data that you're looking.
Exactly, that's really all it is, right? It's some value that falls outside of the normal values that we would expect. And really that's the definition of it. There is no rule that says this is or is not an outlier if this is, a condition that's met. It's up to us as people analyzing the data to say, okay, this could be an outlier. Let's look at why we think it could be. All right, so what we're going to do here is just look at some ways to identify possible outliers to actually know if what we want to do with it or how we want to deal with that data. That's more involved. That's going to take more time. That's going to involve us diving in and finding these different variables and then exploring why the values are larger or smaller. But here we've got a random data set of 1,000 numbers, 4 different columns. So let's just say I know what these values are. Again, they're just random. I don't know what they are, but let's pretend I know. And I know anytime a value is greater than 3, the absolute value of 3, right? So the magnitude is larger than 3. That's a possible outlier. It's a number that shouldn't probably be that big, but I want to explore it further. Well, how can we do that? Well, right away, I'm going to introduce you to np.abs, which is actually going to be a pretty useful little method here. It's absolute value. So if I want to know the absolute value, in this case, if I say a value is larger than larger than 3 or less than -3, in other words, the magnitude is larger than 3. Well, I can simply pass this in. The absolute value of my data is greater than 3. So I'm filtering and perfect. None of those filled out as accurate as matching this. So none of the values that we can see, but that's not surprising, right? There's 1,000 values in here and I can see 10 of them. So there's a very good chance that all these dots do contain values that are larger than 3. And in fact, I know there should be some because we have a value of 4 in column 0. And then we have values in 3 in 1, 2, and 3. And if you look, the minimums are all going to be less than -3. So there should be some values. I just can't visually see them, but that's okay. So what I want to do is, rather than evaluate every cell, I just want to return any time that one of these is valued as true. Right? So this is what we have above. If I just add .any1, what's going to happen is, instead of returning the full data set, it's only going to return those values that have met this condition when there's one of them that has. Right? So what that means is, this has met that condition, so it's returning it for us. This has met the condition, so it's returning this value. It's met the condition, it's met the condition, it's met the condition, and so on. So these are the values that we could potentially think are outliers, right? For whatever reason, we said that value of 3 is important to us, and we have sorted our data to find all the times where the value is larger than 3. Now it'd be on us as the people analyzing the data to say, well, why is this value larger than 3? And why is this one? And why is this one? And we'd actually have to dive into the data and see, is this value valid, right? Is it a real value? Does it seem like it's accurate? Or is it probably an error? And there's lots of ways we can go about doing that. We'll discuss them later on. This is just going to be the mechanical step we could take to identify certain values that are, in this case, very large or very small. All right, so that was for the full data set. Maybe that's not actually accurate, and I don't care if there's a value greater than 3 in 1, in 2, or in column 3. Or I'm sorry, 0, 1, or 3. Maybe I only want to focus on one column, which is often the case, because it's unlikely that all 4 of these columns represent the same type of data, and the same filtering shouldn't apply to all of the columns. So maybe I really just want to apply this to a single column, and I just want to show you how to do that. Rather than passing in the full data set, we can pass in the column we're interested in. In this case, I used .loc, which we've used before. Right, so we're going to locate where the absolute value of column 2 is greater than 3. And if you look here, we've gone from what? I don't know, 15 or so observations down to just 2. And you can see that that is 342, which is this one. And it is 635, which happens to be this one. So now we've identified possible outliers in specific columns rather than across all of our data. So that's it. That's the whole thing with outliers. I will spend more time dealing with them and visualizing them and things like that. But this is just a mechanical way for you to identify values that are either very large or very small. It'd be up to you to determine what that outlier value should be, though. All right, so now on to the largest part that we have remaining, which is group by. It was one of the bonus questions I threw onto your homework. It is going to be an incredibly useful tool for you. It allows us to do things that we could do manually, right? We could do things manually, like calculate what are specific stock characteristics, right, for each of the individual stocks in our portfolio, or what are the different mutual fund characteristics across all the different mutual funds, or maybe we want to aggregate across an industry, right? When we want to aggregate something, we could do this with for loops, but it'd be pretty time consuming. It'd probably be pretty tricky to figure out how exactly do we want to do this and all of that. Group by is going to, as the name implies, just allow us to group things together. It's going to allow us to do it in one quick line. So we have this very simple data frame here before we get into an actual one that's a little bit larger. So suppose you wanted to compute the mean of this first column, right? Employment change. Suppose we want to group it by one of the keys. In this case, let's group it by company. And I just want to know, what is employment change, right? So we could calculate what is the average by looping through each of the different names, right? We'd loop through Apple, we'd loop through Bank of America, we'd calculate the mean, or we can simply utilize group by. And what we're going to do is say, take the data frame. In this case, we're interested in employment change just because that's the question I'm asking. Well, what are we interested in doing with employment change? We're going to group it by, in this case, key one, which is the company. Save this as our new data set, and we're going to say calculate the mean. So now what we have is, here's the average of all the Apple observations. Here's the average of all the Bank of America observations. We've done this in a very simple way, whereas, like I said, doing this with a for loop would have been much more challenging. And now here's where we can really see how easy this makes our life. What if I actually want to know, how did each of the companies do in the individual quarters? Well, it turns out we actually have 2 observations for Apple in quarter 1. Don't know why. They reported 2 observations. We want to take account of that. All right, so now getting into a for loop would be very complicated, or at least much more complicated, because now we'd have to loop over not only key 1, but key 2. Whereas using group by, we can literally just pass in both of these keys as a list, right? So here's our list, pass in key 1 and key 2. And now what we have is these mean values, and you can actually check these if you wanted to calculate the mean of these. Here's the mean of Apple in Q1, Apple in Q2, Bank of America in Q1, Bank of America in Q2. Really, the only one you have to calculate is Apple in Q1, because it's the only one that has a double observation. So group by, again, is incredibly useful. It will save you more time than you can imagine, and it allows us to calculate summary statistics, which is the primary reason you'll use it, but you can do other things, but it'll primarily allow us to calculate summary statistics for whatever group we're looking for. All right, so I showed you mean above. Let's just really quickly show you another one, because there's going to be lots, and I'm going to demonstrate a few later on, but just to illustrate that it's not just mean. I don't know why. Maybe you want to know the max value. Well, instead of saying dot mean, we can say dot max. And now we have the largest value for Apple and the largest value for Bank of America. You can see here's the largest Apple value, and here's the largest Bank of America. So 0.52 and 0.69, and you can see that is in fact what it's returned. So it allows us to, again, get a lot of summary statistics very quickly and easily. Okay, so just another illustration. I'm not sure if this one really makes sense in terms of why you would do this, but it'll illustrate how we can use group by in a few additional ways. So here we have a bunch of companies: Citi, Microsoft, Ford, Delta, and Apple. And let's say I want to group by how long a company's name is. For some reason, I think short names are going to be more appealing to customers than long names, so you can read them quicker. Maybe that's what I want to know, right? So I can say people, that is this data set, group by, and instead of passing in a column, right, I'm not going to group by like I did up here, Apple or quarter. I want to group by a function. And we've already looked at length, right? LEN tells us how long is a word. We've done this before. Well, Citi's 4, Microsoft is 9, Ford is 4, Delta is 5, and Apple's 5. So hopefully we'll get the average, or I'm sorry, the sum of Citi and Ford, the sum of Delta and Apple, and the sum of Microsoft, right? So it'll add these together for us. And you can see it actually, that's what it's done. You can confirm this if you were to add up Citi and Ford, right? You get this value and so on. So it's not just used on columns. We can also pass in different functions like length and things like that. So you can aggregate and group by and combine data in countless different ways. You'd be surprised how many unique ways you'll come across doing it. Maybe later on, you're going to want to group stock data by day of the week or hour of the day or things like that. And you can do that very quickly and easily with group by. Here's just a quick little reference for you guys. Just some of the methods available: count, sum, mean, standard deviation, variance, min, max, first, last, all these different things. So are there any questions on group by before we get into actual data set with it? All right, awesome. Let us get into this bonus data set. So this bonus data set tells us how much was the sale, what bonus was earned, was the manager present in the meeting, what day of the week did the meeting take place, was the meeting at dinner or I believe lunch is the other option, and how many clients were present at the meeting. There's a lot of information. First thing I want to do is just really quickly remind us, how do we make new features, right? We've already talked about looking at numbers versus percents and why they're important. So I think it's probably relevant to us to make a new column called bonus percent, right? If I told you made $1, does that matter if your bonus, or $1 million, or whatever this value, these units are? Oh, I don't know. How big is the sale? So let's actually essentially standardize this. So the first thing we're going to do is just make a new variable. Bonus percent. Well, there's no bonus percent column, so we know it's going to make a new variable. It's going to be equal to the earned bonus divided by the sale amount, right? So 1/17 essentially times 100 to make it a percent. And there we go. Now we know this bonus was about 6%. This bonus was about 16%. We have 20, you have 8, and so on. Okay, so if I want to know, was the bonus larger, smaller? What did the bonus look like across different days, and whether or not a manager was present, right? I could, again, make a for loop, go through all of this, and be incredibly time consuming to figure out how. But instead I can just say group by, and I'm going to group it by the day of the week and whether or not a manager was present. And then I'm going to just simply take the bonus percent column and get the mean or the average of it. Right, so here we go. Straightforward, a quick aggregation of the data. I can now answer a very detailed question. What happens to bonus percents, or what happens to your bonuses across different days of the week, and whether or not a manager was present? Turns out on Fridays, you get a bigger bonus if your manager's there. Saturdays, it looks like, yeah, it doesn't necessarily matter. It's not a huge difference, but bonuses seem to be a little bit bigger when managers are not there. On Sunday, if a manager's there, you have a huge bonus. And on Thursday, it appears there's really no difference at all. So very quickly and easily, I can understand this data in a very deep way that would have taken me quite a lot of code to do so otherwise. So another way to accomplish what you see up here, this is the exact same output. I just want to show you how to do it in one line. It's going to really just be up to you what you're comfortable writing code as, right? So this down here is going to accomplish the same thing as up here. I'm going to say, take my bonus data set and focus on just the bonus percent column. What are we going to do that column? We're going to group it by day in manager present. I'm going to calculate the mean. I'm just going to print it out. So really, this is the exact same thing, just done in a couple of lines or one line. You make the decision which code makes more sense when you read it. So next, I want to show you what happens if we don't. I'm just going to enter this and then I'll bring it back in a minute. No, not far enough. It's just too long. There we go. I'll move it back in a minute just so you can see the code. Just because I have it zoomed in, it's a little bit too long to see. So what happens if I don't just want to do one statistic at a time, right? So far I've done mean, I showed you max, I've done one thing at a time, and that's fine. It's been useful. But what if I want multiple statistics? So I have to run this code and copy and paste it a bunch of times, do mean and then do max and do standard deviation? Well, the answer is actually no, right? Rather than saying .mean at the end, I can say .agg. It's going to stand for how do we want to aggregate the data. And I can pass in a list of any of the statistics I want, right? Mean, standard deviation, max, min, it doesn't matter how many there are. Pass in a list of those. And what's going to happen is, put that back to the end, just up there. What's going to happen is it's going to calculate all of those statistics for us. And now you can see Here is the mean value. So 15,165, 15,165, 17,47, 47, and so on. So it doesn't change the value, but instead of getting just the mean, we've got the standard deviation and the max, which are the other arguments we've asked for. So we can get a lot of descriptive statistics for a lot of different groups very quickly using this. So I do want to bring your attention to this. Who can tell me, what does this kind of resemble? What type of data set that we've looked at before? What is this called? Right, it's the pandas one that reminds us of an Excel sheet. It is a what frame?
Data
Yeah,
frame.
right. So this is a data frame, but notice something unique about it, right? Normally we just have one set of bold values on the left, and that stands or represents the index. But in this case, it turns out we have two, right? This is a multi-index, and I don't personally like using them. You can, but notice how Friday is actually, when I hover over it, represents or is associated with no and yes. Saturday is no and yes. Sunday is no and yes, but it's only written once, right? It's just a little bit more confusing to use. So I personally would recommend what I'm going to show you next. Add in an argument after your group by. So in your group by parentheses, right? Here's your parenthesis. You group by, you're going to tell what to group by. You group by, these two columns. We're going to add in this argument. You're going to say as index equals false. And I almost always do this by default. What it's saying is, don't return these as indexes. Return these as just actual columns of data in a data frame that you or I can use like we would use any other bit of data. So I run this. Now look at what's happened, right? Day has been filled in as an actual value. It's a column that I can reference. If I wanted to filter by day, now I can do that easily. If I wanted to do something with manager present, I can do that. They're no longer index values. Our index is just the way we normally look at it, 0 through 7. These are just normal columns in a data frame. So I would encourage you to mostly use as index equals false, unless you want to explore working with multi-index data frames, but they do get a little bit more complicated, and I personally don't use them very often for that reason, right? This is much easier to use. All right, so who can explain or guess why this next line is relevant, right? We can fill in missing values with group by. Why would I want to do that? What does it mean? Why would it be helpful? What do you think? Why might group by be a useful way to approach missing data?
We would be able to update data in spots that we need it.
Yep, yeah, we can, right? We can update data in spots that we want but much more precisely than we could beforehand, right? Using our skills prior to this. So what I mean by this is, let's say we have a bunch of mutual funds. Some are growth, some are value, and some are international. Let's just say those are the only 3 types we have, and there's missing data across all of them. How could we, just in, use some plain English, how could we use group by, or how would you utilize group by to fill in missing values across those? Right, not in code, just kind of explain it in just English.
Could you like group by NaN and then fill it with whatever you needed to fill it with, like mean or?
We could probably fill group by NaN, but that would actually just put all of them together. So I'm looking for something else.
Okay.
So would you expect growth mutual funds to be more similar to growth mutual funds, or to be more similar to international mutual funds?
Growth.
Right. Okay, so I think that makes sense, right? Growth funds should be similar to growth funds. value funds should be similar to value funds, international funds should be similar to international funds, or whatever classification you're using. So we can utilize group by to take advantage of this rather than calculating, let's say, the average of every observation and filling in missing values. What if we calculated the average of just international funds and filled in missing international funds with just the international fund average? And now we calculated all the growth funds and calculated their average, and then all the growth funds that have missing values are only filled in with the value from growth funds. And same with value. Now our ability to target missing values with appropriate or with more refined methods for filling in values has increased quite a bit. All right, so here's some data. All I've done up here is filled in a bunch of random missing values, and I've just made the data set a little bit smaller so we could see it. So for whatever reason, we have these missing values and we want to fill them in. Let's make the assumption that something happens on Sundays that is different than on Saturdays, right? Those are the only two dates we have. Well, we can calculate something across just a Sunday and use only values from Sunday to fill in for Sunday. We can calculate something entirely different for Saturdays and fill in just those Saturday values for Saturdays. Similar to the example where I said, here's what the value for growth funds is, we'll fill that into growth funds. So I'm going to show you a forward fill, but you could do any method. We could do, dot mean, anything we've done before, but I'll just show you a forward fill example, right? So if this is our data set and we want to fill in earned bonus by day of the week using forward fill, I'm just going to zoom out one so we can see the data set. There we go. Here's our earned bonus. Here is day of the week. I mean, it doesn't even matter that it's going in reverse order. Sundays before Saturday doesn't make a difference, right? And I'm going to use forward fill. Okay, so what value is going to be filled in here? What should these two have?
1.66.
1.66.
Yeah, exactly. It's going to fill those in. Perfect. 4.71. Where or how far down is that going to forward fill? Tell me the last number that it's going to fill in.
18.
18, is that what you said?
Yeah.
Yeah, that's exactly right. Forward fill, before we knew how to group by, would have filled in all the way down to 2.75. However, now that we're grouping by day of the week, forward fill is actually going to stop at 18 because, well, the next day is Saturday. It can't continue to forward fill even though there's missing value because the day of the week, the group has changed. So if we run this, there you go. 18 is the last one it filled in as. And the last thing I want to show you with filling in data is, right, we have this here, but it's only that one column. What if we wanted to fill it into the original data set? Well, you guys should be able to guess how to do it. We're just going to take that original data set and say earned bonus, which is that column that we're working with, and then set it equal to the exact code we wrote above. All right, so now we do it. There you have it. It's been filled in down to cell 18. Now we have our full data set filled in with the best way that we knew how. Maybe we want to now run this again, right? Maybe what if I did this again? But instead, right, I use vfill, right? So first I forward filled everything. Oh, look, I still have some problems here. I don't have these two observations on Saturday. I can't forward fill these anyways because, well, we can't forward fill a value that's not there, right? Here's Sunday, can't go forward and there's no date. So maybe I want to then, after I forward filled, backfill. Maybe I want to fill in 275 into both of those. Well, I could very easily just accomplish that right there. Now I've got all my data filled in, right? So it's pretty easy to see how group by can allow us to do a lot of things very quickly and easily and do some things that are pretty customizable. So for the last bit of tonight, it is very easy. I would recommend you just literally copy and paste the code. It is combining data sets, and so far everything we've done has been in a single data set, right? You've gotten a data set, we've loaded that CSV, we've worked on that file, and that's been that. But starting in your second assignment and in the real world, data sets are going to come from 2, 3, 4, 10 different locations, and we have to figure out how to join them together. So we have here are 3 different data sets. Each one has 20 days in it as weekdays, and is going to be sales for January, February, and March. And the first way I'm going to show you how to combine data is just pd.concat, and it's just a list of the data sets. This is the simplest way, and literally when your data sets are the exact same columns, right? Same setup, you can do this if you want, and it will just stack them on top of each other. So there you have it. There are 20 entries in each one. There are 60 total entries, date, company, product, and units. So now we have 20, 20, 20 for 60. And if I actually just do a random sample, you'll notice here is January, here is March, January. If I run sample again, there we go. Now we've got a February in there. So you can see it's combined the January, February, and March sales into one data set. So that is just pd.concat. So by default, concat is going to stack them vertically. However, if you want to, and it does not make sense in this data set, but I will show you how, because there could be times when you want to, if you want to stack them left to right instead of top to bottom, you can just pass in axis equals 1. It's the exact same code. And now look at what this data frame looks like versus this data frame, right? This data frame has date, company, product, and units, same columns, but notice this is only January. Then it repeats date, company, product, units for February, date, company, product, units for March. So again, you can stack vertically or horizontally depending on what your needs are. You can do that pretty quickly with pd.concat, which stands for concatenate. And then lastly, the way you'll probably do most of your data combining is known as a merge. And there's a bunch of different merge types. There's outer merges, there's inner merges, there's left, and there's right. And I'll show you what all those are in a minute. They're actually very simple to remember. What we have here is data set gold and data set bronze. So this is going to be minerals produced by different countries, and we'll open them up. I'll open up both of them. So we have a company, or I'm sorry, we have a country abbreviation, country name, in total. All right, so let's say this is how much gold's produced. This is how much bronze produced in this country. And here we have these 2 different data sets. Our goal is to combine them, right, to merge them together so that we have gold and bronze together in one data set. All right, so how do we do that? Well, let me try and fit it on the screen. We're going to use this code right here. And I'm going to explain what each line of it means. And it'll be pretty straightforward, I think, once you see it once. pd.merge, right? And then you are left with open and close parenthesis. We're going to list the 2 files first, right? The 2 files that we want to merge together are right here. They're the first 2 arguments. First one was called gold. There it is. And then bronze. The next argument is called on. On simply represents what variables are you going to match on, right? We need to be able to match these 2 data sets by something. In this case, I'm going to say we need to match abbreviation and country. So in other words, where this says USA and United States, it's going to find USA and United States down here, and it's going to match those 2 rows together. So hopefully in the end, we'd have 2088, and right next to it is a new column, 1052. So I want to delete that for a minute. How equals outer, you can ignore that for right now. I just want to show you what this output looks like. So here's what we're left with. Abbreviation, country, total X, and total Y. Now total X refers to gold because this is the X. Total Y refers to bronze because this is the Y. The first one is X, the second one is Y. That's by default. Now, the bit of code I took out said suffix, and then I had a list. So I find total X and total Y to be incredibly confusing, especially if in 10 lines of code, I forget which one I listed first, right? The only way to remember what X is to remember which one listed first. So I'd recommend using something like this: suffixes equal, pass them in, and now when we run it, instead of X and Y, it says, here's total gold produced, or whatever you want the variable to be, and here's total bronze produced, right? So it's kept the word total, instead of putting underscore X and Y, it's put underscore bronze and gold. So now my data set actually makes sense to me. I've got the country, the abbreviation, and I know how much gold was produced, how much bronze was produced. I've combined these two data sets. I'll talk about how when we get down to this next line. Once we're done, I'll talk about the different how options, but they're pretty straightforward. All right, so now let's open up silver, because this is going to often be the case. So here we have silver, and we're going to try and combine that with gold, just like we did with gold and bronze, but there's going to be one big difference. Notice that silver does not have abbreviation. It now has the column name label. Okay, so up here, when we did on equals, it's not entirely clear how can we combine these, right? Abbreviation isn't in both. I can't put the word label there because label's not in both. If I have different names from different variables or from different data sets, what do? Well, the code gets longer, but it's actually not any more complicated. Let me just scroll over. Let me enter that down just so we can see everything. Okay, so here we have our merge. Again, gold and silver, just like gold and bronze above. Instead of saying on, now we have to say left on and right on, right? And this literally refers to which data set is on the left. Well, here's our two data sets. Gold is literally listed to the left of silver, so that is left, gold is left. Silver is listed to the right of gold, so that is the right. So all we do is, instead of saying on, we say left on. Gold should have abbreviation and country. Right on, silver should have label and country. And what is happening is it is matching abbreviation to label and country to country. Even though the column names are different, it knows that just because the titles are different, the values in them should still match. Everything else is the same: gold produced, silver produced, how is outer. When we run this, we are left with the output that we would hopefully see, right? 2088 and 1195 for USA. We have abbreviation, country. We now have the additional column of label because we do have those just different column names. We could drop that later on if we wanted, but that is merging of data. Okay. Any questions on merging before I just quickly explain the difference between the how methods?